An, an equilateral triangle ABC with side A is revolved about the straight line PQ through B that does not intersect the triangle anywhere else. The angle alpha between line AB and PQ is between pi by 4 and pi by 2. Find the surface area of the solid generated by rotating triangle ABC about the straight line PQ. The figure in the right shows all the data given in the question. We are required to find the surface area of the solid generated by the rotation of triangle ABC about the axis PQ. Now, let me narrate again what are the facts given. This triangle ABC is a right angle triangle, it is an equilateral triangle with side, let us say, A. PQ is a straight line passing through Q. This angle is alpha. The angle between AB and PQ is alpha, and that angle is between 45 degrees to 90 degrees. Now, this triangle, this equilateral triangle is rotated about this axis, and we are required to find out the surface area generated by this rotation. Now, let the distance of A from PQ by R1. If AF is the perpendicular from A onto the axis PQ, then R1 is the radius of this circle or this line. Similarly, if you drop a perpendicular from C to G such that CG is 90 degrees to PQ, then R2 will be the radius of rotation given here. This problem is more about visualization of the geometry than about difficult mathematics. Now let us take the surface areas generated by different lines one by one. Let us take line AB. This line AB generates the curved surface of the cone ABD. This is a cone with the base which is circular and the axis which is 90 degree to it. Therefore, it is a right circular cone. A is the slant height. R1 is the radius of the base. For such a cone, the curved surface area is pi A R1, where A is the slant height and R1 is the radius of the base. This is a standard formula for a right circular cone. If you do not know this, please verify this from your geometry textbook. This area is generated at the bottom of the whole figure. The second area that is generated is when line BC is rotated about the axis PQ. This is generated at the top of the figure, that is in this area. Now here again, it is a right circular cone with slant height A but radius r2. So the curved surface area generated by this line on rotation about the axis PQ is pi a r2, because in this case radius is r2. Finally, the third area that is generated when line AC is rotated about the axis PQ. Here it generates a solid which is like this. It is called a frustum, the frustum of a right circular cone. That is, this was the cone, a part of it has been taken out, that is, this part is taken out, and the remaining part is the frustum. The curved area of the frustum is given by pi a multiplied by r1 plus r2, where r1 is this and r2 is this radius. Again, this is a standard result. If you do not know this, please look up in your geometry textbook. Thus, the total surface area generated by the three different rotations, that is 1, 2 and 3, is pi a r1 plus pi a r2 plus pi a r1 plus r2. And if you take pi a common from all the three terms here, we get pi a multiplied by r1 plus r2, again r1 plus r1 plus r2. That is 2 pi a multiplied by r1 plus r2. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. More importantly for me, if you like, share and subscribe, it would encourage me to make and post new videos for you to view. Also, if you know about any interesting problems that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. Sin alpha is equal to r1 by a. Look at the figure. This is angle alpha. This triangle is a right triangle because this angle here is 90 degree. So, sine of this angle alpha is equal to this divided by the hypotenuse, which is r1 by a. Hence, r1 is equal to a sin alpha. Note that angle CBG, that is this angle, plus angle CBA, that is this angle, plus angle ABF, that is this angle, together this plus this plus this is equal to a straight angle which is 180 degree. Therefore, CBG plus angle CBA is 60 degree because this is an equilateral triangle, and equilateral triangle, all the angles is 60 degree, therefore this angle is 60 degree. So here instead of angle CBA we can write 60 degree, and this angle is given to be alpha, this angle. So this angle plus this angle plus this angle being 180 degree, we get this angle is is equal to 180 degree minus 60 minus alpha. That means 120 minus alpha. So, angle CBG is equal to 120 degree minus alpha. From triangle CGB, that is from this triangle CGB, sine of angle CBG, that is sine of this angle, will be P divided by H, which is R2 divided by A. CG divided by CB, that is R2 divided by A. So, sine 120 minus alpha is equal to R2 divided by A. Therefore, R2 is equal to A sine 120 degrees minus alpha, which is R2, that is this radius. Let the total surface area generated be S. Then we had earlier found out the total surface area is equal to 2 pi A multiplied by R1 plus R2, which is same as 2 pi A multiplied by R1 we have just now found out is A sin alpha, and R2 we have just now found out to be A sin 120 degree minus alpha. Therefore, the whole thing surface area becomes 2 pi A multiplied by this A here, and this A here will be 2 pi A square sin alpha plus sin 120 degree minus alpha. Now, sin A plus sin B is equal to 2 sin A plus B by 2 multiplied by cos A minus B by 2. So, here this is sin A, we can say that this is sin A and this is sin B. Therefore, the quantity within the parenthesis here or the curly bracket here is 2 sin alpha plus 120 degree minus alpha divided by 2, that is half of the sum of the two angles multiplied by cosine of half of difference of the two angles, and that is equal to, if you take out 2 outside, we get 4 pi r square, and this becomes sin 60 degree because alpha and alpha cancel out, and this becomes cosine of 2 alpha minus 120 degree divided by 2, which is 4 pi a square, sin 60 is root 3 by 2, and this becomes cos alpha minus 60 degree, or the whole thing becomes S is equal to 2 root 3 pi a square multiplied by cos alpha minus 60 degree. Therefore, the answer is total surface area S is equal to 2 multiplied by root over of 3 multiplied by pi a square multiplied by cosine of alpha minus 60 degree. Thank you.